Alright, hey there everybody. In the last video for 1-3, we discussed a lot of different properties, and today we're just going to discuss one, and that is the distributive property. Probably one that you guys are familiar with and you've used, even if you don't know that you've used it or knew the name for it. But if not, then this will be brand new for you. Alright, the distributive property is actually made possible by the symmetric property. And all the distributive property is says that when you have multiplication, like you do here, A times B plus C, is that it's the same as A times B plus A times C. And then just so you know that the opposite is true, if you had in parentheses first B plus C times A, it's the same as B times A plus C times A. Here's an example with numbers where 3 takes the place of your A, 2 takes the place of your B, and 5 takes the place of your C. So on the other side of the equal sign, you have 3 times 2 plus 3 times 5 gives you 6 plus 15, which equals 21. So you take the 3 times the 2, add it to the 3 times the 5, and you get 21. Okay, I'm not going to lie to you on this one. This one is a little bit, it's a little bit tricky. It takes a little bit of practice. But they want you to get used to solving multiplication problems using the distributive property. So what they've done is the original problem was 7 times 49. And in the person's head, they did, okay, well, I can use the distributive property. I'll move the 7 out, and I'll make 49 50 minus 1. So then they could multiply 7 times 50, because 7 times 5 is pretty easy, so you get 350, and then you get 7 times 1 is 7. You subtract those two, 350 minus 7 equals 343. That said in words is really complicated. I get that. I understand. You need some problems. You need to practice it and get the hang of it. It's kind of hard to discuss over a video. But that's the idea that they want you to get and to eventually use to solve complicated multiplication problems in your. Here is some that you could try on your own, because practice makes perfect. So pause the video, don't use a pen and paper, and see if you can do these in your head. Alright, to do this in your head, hopefully you broke it down into 15. And then you could do 300 plus 4. Because that 300 plus 4 will give you that 304. Then you do 15 times 300, and you should have got 4,500. And 15 times 4, which is 60. And you add those two together, and you get 4,560. On the second one, this was originally 82 times 12, but it's broken into 82 times 10 plus 82 times 2. And the reason why I did that was to hopefully kind of give you a head start. So when you do 82 times 10, you should get 820. And then you add that to 82 times 2, which is 164. And when you put those together, you should get 984. If you got those two correct using mental math, hey, congrats. If you didn't, keep trying. Practice makes perfect. It honestly took me a little bit just to, wrestle with it, and then when it finally clicks, it becomes a lot easier. Okay, here we're going to be using the distributive property to rewrite and then solve expressions. So the original expression was 7 times 3w minus 5. And to do that, we need to take the 7 and we need to multiply that by the 3w minus 5. So we take it and we multiply 7 by the first term. So 7 times 3w gives us 21w. And 7 times 5 gives us a 35, and there was a subtraction sign that we need to bring down. So our final answer is going to be 21W minus 35. Okay, on these, I'd like you to try it on your own. Using the distributive property, complete these. Don't worry, it's not that bad. Pause the video, and then unpause it for the answer. All right, if you use the distributive property correctly, you would have got 12 times the y, which would give you 12y, plus 12 times the 3, which would give you 36. And then you're done. That's it. That's all you have to do. On the bottom one, you have 3 different terms that you need to multiply the negative 6 to. So the first one, negative 6 times r will give you a negative 6r. The second one, a negative 6 times a 3g. Be careful, a negative times a positive is a negative 18g. And then the last one, be careful again, a negative times a negative 6 times a negative t is a positive 6t. And that would be the correct answer for those 2 problems. Moving right along, making it quick today. A couple more things that we need to cover. Like terms and the simplest form. Like terms are terms that have the same variable and they have the same power. All right? So even though both of these terms, 5x squared and 2x, have the same variable, they do not have the same power. One is squared and one is just to the first. So these are not like terms. And neither is the negative 4 because it doesn't have an x. Okay? On the bottom, we have a 6a squared plus a squared plus 2a. Okay? I can combine like terms on this bottom one because my 6a squared and my a squared have the same variable and they have the same power. So when I add 6a squared plus 1a squared, I end up with 7a squared. And I cannot combine the last term because 2a does not have a squared next to it. So that stays by itself. This, when I'm in this form, this one here, or like this one up here, when it cannot be reduced anymore or combined anymore and there's no parentheses, this means that we are in simplest form and we're good to go. We're done. Here are 2 problems for you to try on your own in your head. Pause the video like we always do and see if you can come up with the right answer. Combine the like terms. Okay, if you've done that correctly, a 17u plus a 25u should get you a 42u. And you can combine those because they are like terms, they have the same variable, and they are both the same power. On the bottom, you have 6t squared plus 3t minus t. Well, you can't do anything with the 6t squared because the other t's don't have the squared. So that one's as much as you can get. Then you have a plus 3t minus t. Well, 3t minus 1t is a plus 2t. And once I've done that, I have no parentheses. My variables are the same, but they don't have the same power. So that is in simplest form. And I'm done with that one. Here's a couple for you to try on your own again, just to get some extra practice. Combine like terms and make sure that you're in simplest form. Alright, on the top one, we have 4y squared. I'm going to check my expression for any other 4y squareds or y squareds, and I see that there is none. So 4y squared is going to be by itself. Okay? Then I see I have a 2y, a minus 8y, and a plus 5. Well, I know that the 5 does not have a y, so I can't combine that with anything. So I'm concerned with the 2y minus 8y. that has the same variable as well as the same power. So I'm going to do 2y minus 8y because they're like terms. I can combine them. When I do that, I get a negative 6y. And like we said earlier, I can't do anything with a 5 because it doesn't have a y, so it's not a like term. So that just goes on the end there. And that's my solution. On the bottom one, it's written weird. Usually we're used to having our largest term, like our 6x squared, out in front. This one is in the middle. So don't let that throw you off. You just solve it like you do any other one. Alright, in looking at this expression, I see that I only have one x squared term. I have one term with no x at all, that being the 4. And I have two terms, the 7x and the minus 2x, that have the same variable and have the same power. So I can combine those two. I'm going to do the 7x minus 2x. And when I do that, I get 5x. Right? And then I want my leading degree, the negative 6x squared, to be out in front. So I'm going to move that out to the front, and I'm going to take the negative with it. So it's going to be a negative 6x squared plus 5x. And I can't do anything with the 4, so that goes on at the end. So my answer for this one is negative 6x squared plus 5x plus 4. And if you got, 5x minus 6x squared plus 4, or 5x plus 4 minus 6x squared, it's the same thing. All right. One last thing that we need to cover today is the coefficient of a term. And the coefficient is the number that is with the variables. So on our two terms here, we have, on the first one, we have 6a, our coefficient is the 6. On our second term, 12xy, our coefficient is the 12. So whenever anybody says something like, what is the coefficient of, you're looking for the number that is with the variables. So one like, 16x squared y, your coefficient, the number with the variables, is 16. All right. I hope this helped some of you. With that mental math and using the distributive property, don't get frustrated with it. Keep working on it. Practice makes perfect. Eventually it'll come. Have a good one, guys.